Here I am going to share my screen. Is it visible to all, the PowerPoint presentation?
Sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
In MSc semester 1, as I said, the paper number is CHE. Still someone is joining. મેં આ બીજી સ્ક્રીન સ્ટાર્ટ કરી છે તો મારો અવાજ આવે છે આપને?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
ઓકે, થેન્ક યુ. એટલા માટે બીજી સ્ક્રીન શેર કરવી પડે છે કેમ કે અમુક લોકો હજી મીટિંગ જોઈન કરે છે. Okay. So as I said, in semester 1, we are having two papers, CHE 405 PR and CHE 406 PR. So CHE 405 is associated with organic and inorganic chemistry. General information for the organic chemistry practical. So in MSc semester 1, we are having practicals that is called organic preparation. In organic preparation, all organic preparations are one-step organic preparations. So as we know, one-step organic preparation means you have to complete the reaction by one step only. Means suppose if you want to synthesize any compound, then you have to carry out reaction, either nitration, bromination, esterification, alkylation, acylation, whatever, but one step reaction only. So what we will discuss in this one step reaction, we have to explain or discuss about the principle of the reaction, general reaction mechanism, mole ratio calculation, and purification of compound, melting point and boiling point of the compound. If it is solid, then we will go for the melting point. If it is liquid, then we will go for the boiling point. Then TLC. TLC means thin layer chromatography. Now here TLC we are going to perform. The TLC is not for the confirmation of the compound. The TLC is for the checking of the progress of the reaction. Means when we are doing any kind of reaction, then physically sometimes we may get idea that the reaction is in progress or not. But every time it is difficult to check the progress of the reaction is in forward direction or not, or something happen, or some intermediates are forming or not, that we can't see by naked eye. But with the help of the TLC, that is called thin layer chromatography, we can check the progress of the reaction. But as I said, TLC is not for the confirmation of the product. It is only for the checking of the progress of the reaction. So during any synthesis, whether reaction is in forward direction or not, or initiated or not, intermediates form or not, that we can confirm it by TLC. As per the syllabus, as I said, it is a combination of organic and inorganic. Means the paper 405 is associated with organic and inorganic chemistry. So organic chemistry having 35 marks and inorganic chemistry having 35 marks. So total is 70. Same way for internal exam, out of 30, 15 marks from organic chemistry and 15 marks from inorganic chemistry. So likewise, you will get the 100 mark of the practical. So 70 for external and 30 for internal. Now out of 70, here we are going to talk about the organic, means 35 marks only. So how the marks distribution as per the university exam. If it is internal exam, then marks distribution may be little bit differ. But here I am going to talk about the university exam. So principle and reaction mechanism. Principle in reaction mechanism means you have to write the reaction and what is the concept behind the particular preparation, and its reaction mechanism will carry 5 marks. Mole ratio and other calculation will carry 5 marks. Crude and crystal have
સર તમે મ્યુટ થઈ ગયા. સર તમારો વોઇસ નહીં આવતો.
હેલો, હવે અવાજ આવે છે?
હા સર.
Yes, sir. Yes, sir.
શરૂઆતમાં જે મેં ડિસ્કશન કર્યું એ કશું નથી આવ્યું?
ના આવ્યું તું. આવી કમ્પ્લીટ.
Okay. Again, I am repeating distribution of marks as per the university exam. In the university exam, principle and reaction mechanism will carry 5 marks. Mole ratio and other calculation 5 marks. દરેક જણને રિક્વેસ્ટ છે કે તમારા માઇક ઓફ કરો. ઘણાના માઇક ચાલુ છે. દરેક સ્ટુડન્ટને રિક્વેસ્ટ છે કે તમારા માઇક ઓફ કરી દો. Crude and crystal 10 marks, purification and melting point and boiling point will carry 5 marks. TLC
તમારું માઇક બંધ થઈ ગયું સર.
Sir, you are muted.
હવે દેખાય છે સ્ક્રીન અને વોઇસ આવે છે?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
કોઈ એક સ્ટુડન્ટ આન્સર આપશે?
Yes, sir, it's visible now. Audio 2 is coming.
મારો અવાજ આવે છે?
हाँ sir.
Yes, sir.
Yes, sir.
હેલો હેલો.
Yes,
Yes,
हाँ
sir.
sir, આવે છે.
ઓકે. દરેક સ્ટુડન્ટ પોતાના તમારા જ્યારે હું બોલતો ત્યારે ઓડિયો બંધ કરજો, કેમ કે અમુક લોકોને વચ્ચે વચ્ચે સાઈડ નોઇઝ આવે છે. Now, types of preparation. સ્ક્રીન દેખાય છે? કોઈ એક આન્સર આપશે?
હા સર દેખાય. Yes, sir.
સાઉન્ડ પ્રોપર હવે આવે છે?
Yes. Yes, sir.
Thank you. Now, types of preparation. As per the syllabus of MSc semester 1, nitration, bromination, acylation, reduction, oxidation, condensation, diazotization, Friedel-Crafts reaction. So these type of reactions are there, or types of preparation are there. In each preparation, either one or two more preparation are there. Means in nitration, 2 preparation, bromination, 2 preparations, acylation, maybe 1 preparation, likewise. So total near about 15 or 16 practicals are there. Here the types of preparations. In nitration, preparation of metadinitrobenzene from nitrobenzene, para-nitroacetanilide from acetanilide. Same way in bromination, acetylation, reduction, we are having preparations. We are having preparation in oxidation, condensation, then diazotization. In diazotization, preparation of methyl orange and methyl red. And the last one is Friedel-Crafts reaction. In Friedel-Crafts also we are having 2 preparation. So today I will focus on nitration and diazotization reaction. But when we start any preparation, you should know about some basic things related to organic reaction. First of all, unit process. So what is unit process? Unit process is the phenomenon in which the chemical changes of matter take place. એટલે કે એવી યુનિટ પ્રોસેસ કોને કહી શકાય કે જ્યાં આગળ કેમિકલ ચેન્જ થતો હોય. એટલે કે એક કેમિકલમાંથી બીજા કેમિકલ એટલે કે એક કમ્પાઉન્ડમાંથી બીજા કમ્પાઉન્ડમાં કન્વર્ઝન થતું હોય એને યુનિટ પ્રોસેસ કહેવામાં આવે છે. Now unit operations. Unit operation is a phenomenon in which conversion of matter, or we can say physical change of matter take place. એટલે કે કોઈ મટીરિયલ છે અથવા કોઈ કમ્પાઉન્ડ છે એની ઉપર કોઈ ફિઝિકલ પ્રોસેસ થઈ રહી છે. Now what is physical changes? The physical changes we can call increase or in temperature, decrease in temperature, stirring, then conversion of solid to liquid, liquid to gas. Sometimes if you are having some material and with solvent, then removal of solvent and to get the pure product, that is called filtration, that is also known as physical operations. Then distillation of one or two solvents from the mixture, that is also called physical operation. Drying is physical operation. There are several types of physical operations are there. All physical operations we can consider into or we can keep into unit operations. So again repeating, unit process means chemical change of matter or material take place. Unit operations means physical change of matter or material take place. Then requirement of chemicals means when you going to start any preparation or synthesize any compound, you must have some requirements. Means requirement of your chemicals. That chemical may be solid, liquid, gas, and not only chemicals we require apparatus also for the particular type of preparation. Now once we are having chemicals, then based on the chemical reaction, we have to find out the mole ratio. Now mole ratio means how much amount of particular compound required for the synthesis, and with respect to that material, what other chemicals or what types of other reagents and quantity of the particular reagents and chemicals are required, that is called mole ratio. Then
आपको कोई म्यूट कर रहा है?
हाँ,
आप कर सकते हो? कौन है? आपको कोई म्यूट कर रहा है? मेरे को मैसेज आया है। स्टूडेंट ने मुझे व्हाट्सएप किया,
इसलिए मैंने अब मैं ऑर्गेनाइजर में आ गया और
बस
मैं ऑर्गेनाइजर, मुझे समझ में आ गया। ये तो जिस दिन
लड़के ने मेरे को बोला कि पटेल को कोई म्यूट कर रहा है, आप जाओ ना।
हाँ नहीं, मैं इसमें था पहले, इसमें से कर रहा था, तो बार बार मेरे को म्यूट कर रहा है। कुछ नहीं, मैंने रिकॉर्डिंग पे रखा है, जैसे ही खत्म होगा एक्टिविटीज में जाके लॉग में जाके चेक कर लूंगा,
आपको पता चल जाएगा।
और जैसे पता चलेगा उसका तो हम जो करना है करेंगे। ये तो लास्ट ईयर भी तो किया था ना।
कोई जना मिस्टेक कर रहा है
ये यही है, यही प्रॉब्लम है। अगर हम सॉरी स्टूडेंट्स, अगर हम अपने यूनिवर्सिटी के इंस्टीट्यूशनल आईडी से जाते हैं तो कोई कुछ नहीं कर सकता है। इसलिए मैं बोलता हूँ कि एक ही प्लेटफॉर्म पे सब होने चाहिए, तो कोई कुछ नहीं कर। इसमें बाहर के कॉलेज वाला भी घुस गया तो हमें थोड़ी पता चलेगा। इसमें इसका ओपन डोर है ना, उसमें तो अलाउ टू माय ऑर्गेनाइजेशन, बात खत्म हो गया। ठीक है, वो बार बार कर रहा है, मैंने देखा, लेकिन इसलिए मैंने इसमें से निकल के ऑर्गेनाइजर में आ गया है। तो ऑर्गेनाइजर में तो कंट्रोल यहाँ पे रहता है पूरा। मैं पहले इस डेस्क पे था, मुझे लगा कि ठीक से एक्सप्लेन हो, लेकिन समझ में आ गया। थैंक यू सर। મારું સેશન છે ને રેકોર્ડિંગ પર રાખ્યું છે, અને જે પણ મિસશીપ કરે છે લોગમાં જઈને હું ચેક કરી લઈશ, બરાબર। લાસ્ટ યર બી આવા નોટોરિયસ સ્ટુડન્ટ હતા, એમનું તો જે થવાનું હોય અમને ખબર છે કે અમે એમનું શું કર્યું। અમે ક્યારે કહેતા નથી કે અમે શું કરી શકીએ। હું પહેલા ડેસ્ક પરથી એક્સપ્લેન એટલા માટે કરતો હતો કે સારી રીતે સ્ટુડન્ટને એક્સપ્લેન કરી શકાય, પણ અમુક દોડદાય અથવા હોશિયાર અથવા જેના મા બાપે સંસ્કાર ના આપ્યા હોય ને એવા સ્ટુડન્ટ્સ પણ અહીંયા જોઈન થયેલા છે। એ લોકોને મજા આવે છે આ બધી વસ્તુ કરવાની, પણ લોગમાં બધું ખબર પડે છે, અને અમારે એને કશું નથી કરવાનું, અમે એને એક્ઝામમાં બહુ પ્રેમથી જોઈ લઈએ છીએ, બરાબર। તમારે જેટલી મિસચીફ કરવી હોય તે કરો, અને આખી મીટિંગનું કંટ્રોલ મારા હાથમાં જ હોય છે। ઓર્ગેનાઇઝેશનમાં જઈને હું બધું ચેન્જ કરી શકું, પણ આવા ઇન્ટેલિજન્ટ સ્ટુડન્ટ્સને હું ચેલેન્જ આપું છું કે તમારામાં તાકાત હોય એટલી વખત મગજમારી કરો, બરાબર। લોગમાં બધું ખબર પડશે, અને લોગ ખાલી ચેક કરાવતા જ વાર લાગશે મને, એનું શું કરવાનું પછી અમે જોઈ લઈશું। બરાબર. તમારે ભણવું હોય ને તો ભણો, ના ભણવું હોય ને તો તમે કોઈ પકડીને આ ગ્રુપમાં હમણાં એડ નથી કર્યા. લિંક મોકલી છે, તમે લિંક જોઈન કરી છે. તમારે કોઈ કમ્પલસરી તમને લિંક જોઈન કરાવડાવી નથી. અને તમારામાં આટલી બધી સ્માર્ટનેસ કે ઇન્ટેલિજન્સી હોય ને તો કોઈ સારા કામમાં તમારી બુદ્ધિનો ઉપયોગ કરો. બરાબર. અને તમારા બાપા પાસે બહુ પૈસા હોય તો પોતે ધંધો શરૂ કરો, કમાઓ અને જલસા કરો. જે છોકરાના મા બાપ પૈસા ખર્ચીને એમને ભણાવે છે ને એને હેરાન ના કરશો. તો લોગમાં જઈને હું ચેક કરીશ જ આજે. હું એ પણ નહીં કહીશ કે આનું શું થયું અથવા શું કરવાનું. એનું જે કરવાનું હોય અમે કરીશું. તમારી સામે દેખાય છે મીટિંગ ઓપ્શન્સ. એ મીટિંગ ઓપ્શન્સમાં જઈને હું બધું કંટ્રોલ કરી શકું. બરાબર. આ જે લોકોએ હેન્ડ રેઝ કર્યા છે કોઈ ઇસ્યુ છે? સબસ્ટ્રેટ. હવે જેને બહુ હોશિયારી હતી હવે એનો જવાબ આપે છે હમણાં. જેને મને મ્યુટ કરવાનો શોખ હતો એને હું કહું છું કે તું અનમ્યુટ કરીને જવાબ આપજો આ બધા ટર્મ્સનો. આવી ગઈ શાંત ઠેકાણે? જે બી છોકરો કે છોકરી પોતાની સ્માર્ટનેસ બતાવતા હતા ને મને મ્યુટ કર્યો મને. હવે તું પોતાની જાતને અનમ્યુટ કરીને બતાવજો આ બધા સ્ટેટમેન્ટ્સના જવાબ આપ. મને તો લાગે છે કે જે છોકરા આવા હોય ને, ખબર નહીં એના આપણા મા બાપ બી કેવા હશે કે આવા સંસ્કાર આપ્યા હોય. પોતે પૈસા ખર્ચીને મૂર્ખ બનવાવાળા મૂર્ખા પહેલી વાર જોયા. તમે યુનિવર્સિટીમાં જોઈન કરો છો તો ફ્રીમાં નથી ભણતા. તમે લોકો બધા ફીસ ભરો છો અને ફીસ ભરીને ભણો છો. તો પોતાના પૈસા ખર્ચેલા હોય તો પોતે શાંતિથી ભણતા આવડવું જોઈએ. ના ઈચ્છા હોય ને તો તમારા મા બાપને કહો કે એક પાનનો ગલ્લો ખોલી આપે, બરાબર, અને કદાચ તમે ત્યાં સારી રીતે ચાલશો. પ્રશ્નો તમારો નથી, તમને તમારા મા બાપે આપેલા સંસ્કારનો છે, બરાબર. અને શરમ આવવી જોઈએ કે તમે આજે 22-23 વર્ષના થઈ અને તમને અક્કલ જેવી વસ્તુ નથી. અને કોઈના બહુ હોય ને તો એકવાર ડિપાર્ટમેન્ટ આવીને મને મળજો, આપણે ચર્ચા કરીશું. Next one is substrate. Substrate means the chemical or compound on which the reaction will take place. Reaction will take place means which kind of reaction we are going to perform. That is called substrate means the substance on which the reaction will take place. Means we can call say raw material or starting material. Suppose if you want to carry out nitration on benzene, then benzene is known as substrate. Then after the next one is reactant. Means reactants means the substance or chemicals by which the reaction will take place. That is called nitration, bromination, acetylation, alkylation. Which type of reaction will take place, that is depend on the reactant. Then other chemicals.
Can't we say substrate as in some sort of binding site or something? Like enzyme substrate.
Here we are talking about the organic preparation and reaction. In reaction, the substrate means the substance on which the reaction will take place. The meaning of one word in a different field may be differ. Suppose if I am talking about reagent, here the meaning of reagent is the chemical which we can use to start the reaction, and after completion of reaction we will not get it in a original form, but it can initiate the reaction. But if you are talking about the pathology lab or inorganic lab, then reagent means the chemical which we can use for detection of compound. So based on the field, based on the area, the definition or understanding may be differ. But here I am talking about organic preparation, where substrate means the material on which the reaction will take place. Reactant means the material which will attack on the surface, substrate, and the reaction will take place. And reagent means the chemical which can initiate the reaction, but after completion of the reaction it will not available, or we cannot get it in a original form. And last one is a catalyst. Catalyst is a substance which can initiate the reaction, which can enhance the rate of reaction, but after completion of the reaction, we can get it in an original form. Then next one is a solvent. Solvent means why the solvent is required. Normally, whenever we are going to carry out reaction, at that time, the different chemicals are in different physical state. Some materials may be in a solid form, some material may be in a liquid form, some material may be polar, some material may be non-polar, some may be water soluble, some may be water insoluble. So in such situation or condition, if we add solvent, then with the support of solvent, we can convert a homogeneous mixture for the particular reaction. That's why we require solvent. Solvent also plays an important role for the interaction of the molecule. Means once the phase is homogeneous, then interaction may be high. Next one, application or use of solvent. Solvent is required to provide a uniform temperature throughout the reaction, and with the support of the solvent we can heat the material at a fixed temperature or a particular temperature. If we don't use solvent, then based on the other chemicals, the temperature may be differ in a reaction. Next one is the temperature. For any kind of reaction, the temperature plays an important role. Temperature plays an important role means for any reaction we require particular temperature. The temperature may be 0 degree, maybe 5 degree, maybe 10 degree, 25 degree, 100 degree or greater than 100. But for each and every reaction, the particular temperature we require. Then after the time, for any reaction, the fixed time or particular time duration is required to complete the reaction. If we do not provide a particular time or a proper time for the reaction, then we cannot carry out the reaction in a proper way. So time plays an important role in the reaction. Then principle of the reaction means for any reaction, as I said, the reaction will be specific. When we add some reagents, the specific type of reaction will take place. Then general reaction mechanism, mole ratio, purification. Now purification plays an important role when we are doing any kind of organic synthesis. The reason is when we carried out the reaction, the product may be impure, that is known as crude product. Ketan Thakur, તમારો mic off કરો. Purification of the compound why required? When we carried out any reaction, we are having the impure product due to some amount of presence of raw material, intermediate, or some catalyst or some other reagents, anything may be present, or some side reaction. So always we have to purify our product. We will discuss purification in detail when it comes. Then melting point or boiling point. For any compound, after completion of the reaction or after purification of the compound, we have to go for the melting point or boiling point. The reason is based on the melting point and boiling point, what we can confirm the whether the particular product is formed or not, because here you are going to synthesize the product which are already synthesized by someone. So the physical data that is called melting point and boiling points are available in the literature or in a manual. So based on that we can confirm whether product is formed or not. Other confirmation we can do for the formation of the product, that is known as chemical test. Means based on the functional group we can find out whether product is formed or not. Then next one is TLC, thin layer chromatography. So based on thin layer chromatography, we will get the idea whether product is formed or not. So this is the general overview of reactions or preparations where some points are required to understand. So now we are going to discuss about nitration. What is the principle behind the nitration? nitration in the reaction in which when we carried out the reaction using nitric acid and sulfuric acid, we will get nitronium ion or nitrile ion, nitrile ion NO2 plus. That nitrile ion will react with benzene and we will get nitrobenzene. So here substitution reaction, that is called electrophilic substitution reaction, will take place and we will get the product. Likewise, here I have mentioned about the other reactions. But as I said, I will talk about nitration and bromination, diazotization reaction. So I will focus on nitration and diazotization reaction only. Now for nitration, as I said, nitration of compound, what we require? We require nitric acid and sulfuric acid. Now here, what is the role of nitric acid and what is the role of sulfuric acid? Nitric acid acts as a reactant and sulfuric acid will act as a catalyst. Now how it acts as a reactant and how it acts as a catalyst? First of all, from sulfuric acid, the ionization will take place, and due to the ionization, we will get H plus and HSO4 minus. Now that H plus having deficiency of electron, so that's why H plus will react with the oxygen. Why it react with oxygen? Because oxygen having lone pair of electron, so it will convert it into OH2 plus. Now here oxygen having positive charge and its electronegativity is higher as compared to the nitrogen. So oxygen will pull electron from the nitrogen and as a result we will get NO2 plus nitrile ion. We will get NO2 plus. Now NO2 plus having deficiency of electron, which is known as electrophile. This one having deficiency of electron, so it will interact with the pi electron cloud of benzene. When it interact with the pi electron cloud of the benzene, what we will get? The first of all, pi complex formation will take place, and then after NO2 will bind with the particular position. When it bind with particular position, we can see the positive charge on the next carbon. Now, due to the resonance structures, we will get different type of resonating structure, and finally removal of proton will take place. That proton may attach with the water or HSO4 minus. If reaction condition is highly acidic, then it will attach with the HSO4 minus, and from here removal of H plus will take place. So HSO4 minus and H plus will convert it into H2SO4. So we can consider H2SO4 act as a catalyst for this reaction. Second thing, if it is react with water, then it will convert it into H3O plus. Now this H3O plus react with HSO4 minus, so again it will convert it into H2O plus H2SO4. So finally what we can say, H2SO4 act as a catalyst for this reaction and nitric acid act as a reactant for this reaction. And benzene is known as substrate for this reaction. The reason is in the final product we can call it a nitrobenzene. Second thing, on benzene the reaction will take place by this reactive intermediate that is called electrophile, that is called nitrile ion. So nitrile ion attacking on the benzene. So benzene is known as substrate. This one is known as reactant, which is formed from nitric acid, and sulfuric acid is again available in its original form. That's why we can call it a catalyst for this reaction. So this is about the nitration reaction. In organic chemistry, nitration is a chemical process for the introduction of a nitro group into an organic compound. Here we are introducing nitro group on carbon. That's why it is known as C nitration. There are other types of nitrations are also available, or we can call it O nitration and N nitration. But right now we are not going to talk about O nitration and N nitration. We are going to talk about only C nitration. If nitro group is attached on oxygen, then we can call nitrate ester. And if nitric acid is, nitro group is attached on nitrogen, then it is called nitroamine. But as I said, we are not going to discuss about these two types of nitrogen in nitration reaction in detail, but we will talk about C nitration. Now, as per the syllabus, we are having two types of nitration. One is meta-dinitrobenzene from nitrobenzene. Second is para-nitroacetanilide from acetanilide. Now, first reaction, that is called meta-dinitrobenzene from nitrobenzene. Here we are having nitrobenzene. Now, our substrate means this material. Substrate already having one nitro group. Means this group is act as a directing group. Due to the directing effect, the upcoming group will attach at or bind with the particular position only, and that effect is given by this group, that is called nitro group. And based on the characteristic of nitro group, the group may attach on ortho position, meta position, or para position. Now, as we know, nitro group is known as meta-directing. Now, why nitro group is meta-directing group? That we can understand based on the characteristic of nitro group. Nitro group is act as a electron withdrawing group. When it act as a electron withdrawing group, then what happen? It act as a electron withdrawing group. So the position here you can see it act as a electron withdrawing group. So this position ortho to nitro group having positive charge. Then after, due to resonating structure, the para position having positive charge, and then after again the ortho position having positive charge. So we are having positive charge on ortho and para position. So what happened when we are having positive charge on ortho and para position? Then NO2 plus, that is called nitronium or nitrile ion, can attach with the positive charge? No, or less chances to attach at this position. But that nitro group may attach on the, or will attach on the meta position only. The reason is, if we go through the electronic configuration of this ortho position and para position, so at any point of time they are having 6 electrons, where meta position is having 8 electrons. So as compared to ortho and para position, the meta position is rich in electron, and that's why the entering group will attach on meta position. Partial amount of other products or isomers will form due to the resonating structure, but major product will be based on the meta direction, and that's why we will get 93% meta product, 1% para product, and 6% ortho product. So why this 1% and 6% are formed? The answer is here. Due to the certain condition or in situation, these position also having neutral charge, ortho and para. And due to this reason only, the partial amount of ortho and para products are formed. But major product is based on the meta direction or meta at meta position only, and that's why we are having 93% meta product. Now we have talked about the directing effect. Now we are going to talk about the reaction conditions, means other factors. Here we are going to carry out nitration reaction, and for nitration reaction we require nitrating agent, and here as a nitrating agent we are having HNO3 and H2SO4. Now HNO3, as per the general reaction we have discussed, it acts as a reactant for this reaction, and sulfuric acid is act as a catalyst for this reaction. But both or mixture of these two is known as nitrating agent or nitrating reagent. Now, as per the mechanism or reaction, what happened? First of all, as we have discussed, sulfuric acid react with HNO3 and it will convert it into H2O plus NO2, and from this breaking of the bond will take place and we will get nitronium ion or nitrile ion which having deficiency of electron, so we can call it the electrophile. Now this electrophile having deficiency of electron, that's why they are interacting with the pi electron cloud, and as per the resonating and directing effect of NO2 plus nitro group, NO2 group, the most effective or base stable product will be formed at or with the meta position, and that's why we are having meta dinitrobenzene as a major product. Next point is temperature. Temperature, as I said, temperature plays an important role. You are having a substrate, you are having a catalyst, reactant, everything, but if you do not maintain temperature or if we do not provide a particular temperature, then reaction will not take place. So here we require 70 to 80 degrees centigrade temperature. The reason is here we are having one group that is called nitro group, which is known as electron withdrawing group. When this electron withdrawing group is present, then ring will be deactivated. Here you can see ring will be deactivated. Deactivated means what? Ring having positive charge. Now ring having positive charge, it means the entering group having facing some difficulties, and that's why to activate the molecule we require high temperature, and at high temperature the reaction will take place and we will get the particular product. Now here it is mentioned that we require 70 to 80 degrees centigrade temperature. Now if we carrying out the reaction at lower than this temperature, means at 40 to 50 degrees centigrade, we cannot get the proper amount of product in a shorter period of time. Okay, but suppose if somebody is saying or thinking that instead of 80 degree, if we increase the temperature near about 100 or 120, then can we get the product in a shorter period of time? Then again answer is no. The reason is at higher this temperature, means at higher than 80 degrees centigrade, means if suppose temperature is 100 or 110 is there, then third substitution or one more nitro group may attach over here, and that is called trinitrobenzene will form. So the temperature plays an important role in any reaction. So for particular product or desired product, we have to maintain the temperature. So if we do not maintain the temperature, we may get unwanted product or the reaction will not be in a favored direction if low temperature is there. So particular temperature is essential for any reaction. Here is the mechanism. Now based on the reaction and reaction mechanism, we have to find out the mole ratio. Now how to find out the mole ratio? To find out the mole ratio, what we have to think about? Here we are having your substrate. It means raw material on which we are going to carry out the reaction. So based on this, we can calculate the remaining materials quantity, okay, or mole ratio. Normally, if we looking to this reaction, then we require 1 mole of nitrobenzene, 1 mole of sulfuric acid and 1 mole of nitric acid. This is the normal reaction condition, but actually when we are going to carry out the reaction, at that time we require higher amount of sulfuric acid. Now what is the reason behind this? Why higher amount of sulfuric acid we require? The reason is here to break this bond. Okay, this is positive and negative, so stability is there, but to break this bond we require another mole of sulfuric acid, and as per the calculation we require 2 mole of sulfuric acid, 1 mole of nitric acid and 1 mole of nitrobenzene. So this we required, and then after we can carry out the reaction. So based on the mole ratio, now we can say that nitrobenzene 1 mole, fuming nitric acid 1 mole, and concentrated sulfuric acid 2 mole. As per the reaction, we can see 1 mole is required, but actually to break this bond we require another mole of sulfuric acid, and that's why to carry out reaction in a better way we have to use 2 mole. If we do not use 2 moles, if we use only 1 mole, then also the reaction will take place, but reaction will take longer time. The reason is whatever sulfuric acid is formed during the reaction, that sulfuric acid will react with the water. So strength of the sulfuric acid is decreases. When strength of sulfuric acid is decreases, then ionization or rate of ionization is also slow. So to avoid such problem, we have to use 2 mole of sulfuric acid. ફરી અહીંયા આગળ તમે reaction જોશો તો શું બનશે H3O plus એ HSO4 minus જોડે bind થઈ જશે. એટલે થશે એવું કે જેટલો મોલ સલ્ફ્યુરિક વોટર જનરેટ થાય છે એટલા મોલ સલ્ફ્યુરિક એસિડના યુઝ થતા જશે. એટલા કારણથી જો 2 મોલ સલ્ફ્યુરિક એસિડ યુઝ કરીએ તો આ ફર્સ્ટ સ્ટેપનું જે જનરેશન ઓફ નાઇટ્રોનિયમ આયન છે, નાઇટ્રાઇલ આયન છે, એ થતું જ રહે, કન્ટિન્યુઅસ પ્રોસેસ રહે અને રિએક્શન શોર્ટર પીરિયડ ઓફ ટાઈમમાં કમ્પ્લીટ થાય. એટલા માટે 2 મોલ યુઝ કરવામાં આવે છે. Now, your substrate or our substrate is nitrobenzene. So all calculation will be based on the nitrobenzene. Suppose I would like to start reaction with 5 gram. Now, as we know, nitrobenzene is a liquid form. In a liquid form, what is the density of nitrobenzene? Nitrobenzene having 1.2 gram per centimeter cube. This is the density of nitrobenzene. It means what it says. If we take 1 ml, then the weight of that nitrobenzene is 1.2 gram. Now, if such situation is there, then if you want to get the particular amount of material, then what we have to do? We have to find out its ml. Now, how we can calculate the ml? There is a simple formula, D equal to m by V. D means density, m means mass, and V equal to volume. Let me attach the wait for a minute. I am attaching my pad. Okay. So suppose I would like to take 5 gram. Then what I have to do? I have to go for the calculation D equal to M by V. When I'm talking about D equal to M by V means I'm having the value of density that is called 1.2. So 1.2. Mass is fixed means I would like to take 5 gram. Okay, but I am not aware that what ml I have to take. So this is the equation. Now V equal to 5 by 1.2. Now based on this, we will get this value 4.2 ml. So if I have to start the reaction with 5 gram, I have to take only 4.2 ml. Remember, don't take 5 ml. You have to take 4.2 ml nitrobenzene. Then the volume of that nitrobenzene will be what? Amount of that nitrobenzene will be 5 gram. I think you are familiar with this formula and I don't think any confusion is there. Then after I have started with what? 5 gram. So now what will be the mole of that 5 gram? મારી પાસે 5 gram નાઇટ્રોબેન્ઝીન છે તો 5 gram નો મોલ કેટલા હશે? તો how to find out that mole? એક જ મિનિટ. કૃષ્ણા ચુડાસમા મેં તમને હમણાં જોઈન કર્યા છે. માઇક ઓન કરશો? કૃષ્ણા ચુડાસમા માઇક ઓન કરશો?
યસ સર.
આપણે મીટિંગ કેટલા વાગે હતી?
સર તાવ આવ્યો તો દવાખાના ગઈ હતી એટલે.
ઓકે ફાઇન. સારું. Now if you want to find out this mole, how we can find out? So mole equal to means what? Gram per mole. Molecular weight divided by the. If you want to find out particular mole, here, then what we have to do? We are having required gram 5 divided by molecular weight. So if you go for the calculation, then it comes to 0.04. This is the mole of what now? This is the mole of nitrobenzene. Now, if you are having the mole that is called 0.04 mole, then based on this only, we have to go for the other calculation. Now, as per this formula, for 1 mole of nitrobenzene, we require 1 mole of nitric acid. So what will be the mole of nitric acid? That is called 0.04. The reason is you have to multiply this with this. Okay. Now, as per the reaction, what mole of sulfuric acid we require? That is 2 mole. So multiply 0.04 with 2 mole. So what we will get? We will get 0.08 mole. So now we are having mole, but we are not having the exact amount of the substance we require for the reaction. So that's why what we have to do again. This mole means 0.04 into 63. એટલે આપણે આ કરવું પડશે 0.04 into 63. So suppose we will get Y gram. Okay. But as we know, this nitric acid is in a liquid form. So again, we cannot go for the way of this compound that is called nitric acid. Nitric acid નું આપણે વજન કરવા નહીં જઈએ. આપણે શું કરવું પડશે? nitric acid નું વોલ્યુમ લેવું પડશે. Again, we have to use the same formula, D equal to m by V. Now you are having density of nitric acid. So you have to write the value of that 1.52, that is called density. You are familiar with the how much gram of nitric acid we require, and then after we can go for the calculation of V, that is called ml. V equal to m means Y, whatever you are having over here. આ તમારો જે આવ્યું અહીંયા લખશો, and then after 1.52. So you will get, suppose A ml. That A ml we have to use and we have to carry out the reaction. Same way sulfuric acid. Now sulfuric acid, based on the concentration, it having different types of density. But normally, if you are having AR grade, that is called 98% pure sulfuric acid, then its density is 1.84. So what you have to do? 0.08 into 98. So you will get the Z volume, Z gram. Now Z gram equal to, you have to convert it into ml. So D equal to m by V. So again, D is 1.84 equal to m means your Z gram, and V we have to find out. So this is, by this way we can find out the volume of sulfuric acid. Here I have given the calculation directly, but I am going to show you how to calculate. I have prepared Excel sheet that I can show you how to calculate the mole ratio. Here, red color. In red color, I have shown the amount of what? Nitrobenzene. So as we have discussed, nitrobenzene, what amount of nitrobenzene we required? We require nitrobenzene 5 gram. So based on that, what we can find out? Based on that, we have to find out the mole. So as I said, how we find out the mole? 5 divided by 123. Here the equation આપ્યું છે. D2 by B2 into C2 means અહીંયા આગળ તમારું કેટલો છે? D2 5 divided by 123 એટલે તમારું કેટલું આવશે? 0.64. જો કોઈ કેલ્ક્યુલેશન કરવું હોય તો કરી શકાય. બરાબર? તમારી પાસે કેલ્ક્યુલેટર કે મોબાઈલ હોય તમે કેલ્ક્યુલેટ કરશો તો તમારે આ વેલ્યુ આવશે. Then we have to find out the mole of what? Nitric acid. So for nitric acid, what we have to do? This into this, matlab 0.04 into 1. For sulfuric acid, 0.04 into 2. So we are having 0.08. પેલા પીપીટી ની અંદર તમને મેં અલગથી કેલ્ક્યુલેશન કરીને બતાવ્યું. અહીંયા આગળ એક્સેલ શીટનો ઉપયોગ કર્યો છે. હવે આ એક્સેલ શીટ તમે જે લોકો માઇક્રોસોફ્ટની અંદર એક્સેલ યુઝ કર્યું હશે એમને ખબર હશે કે એના બેનિફિટ શું છે. બેનિફિટ એ છે કે આખો એકવાર પ્રોગ્રામ રન કરી દીધા પછી તમે કોઈ એક રેશિયો અથવા એક જગ્યાએ ચેન્જ કરો તો ઓટોમેટિકલી બધી જ વેલ્યુ ચેન્જ થશે. કેવી રીતે કે અહીંયા આગળ મેં 5 ગ્રામ લીધું છે. હવે અહીંયા આગળ હું 5 ગ્રામને બદલે 10 ગ્રામથી રિએક્શન કરવા માંગુ છું. દરેક જણા એક્સેલમાં ધ્યાન આપે કે કેવી રીતે એ વેલ્યુ ચેન્જ થાય છે. અહીંયા હું ટાઈપ કરીશ 10. આ જો ફિગર ચેન્જ થશે. થઈ ગયું 0.08 થઈ ગયું 0.08 થઈ ગયું 16 થઈ ગયું. હવે હું અહીંયા ફરી પાછું વેલ્યુ ચેન્જ કરું છું અને મારે ફક્ત 2 ગ્રામથી રિએક્શન કરવું છે. તો અહીંયા આગળ હું 2 લખીશ 2 ગ્રામ. ઓટોમેટિકલી તમે જુઓ કે આ બધા વેલ્યુઝ ચેન્જ થાય છે અને આ વેલ્યુ અહીંયા જ નથી ચેન્જ થતા. આખા રિએક્શનના જેટલા બી બીજા મોલ રેશિયો મેં કેલ્ક્યુલેટ કરેલા છે ત્યાં બધે ચેન્જ થાય છે. ફરી આને ઓરિજિનલ 5 ગ્રામથી આપણે સ્ટાર્ટ કર્યું હતું તો એને હું ફરી 5 ગ્રામ કરી દઉં છું. એટલે અહીંયા મારે 0.04 થયું. Amounts of substance required, that is 5 gram. હવે એના રિસ્પેક્ટથી જ્યારે 5 ગ્રામ મને નાઇટ્રિક એસિડની નાઇટ્રોબેન્ઝીનની જરૂર છે તો એ સમયે મારે નાઇટ્રિક એસિડની જરૂર છે 2.5. એ સમયે સલ્ફ્યુરિક એસિડની જરૂર છે 7.8. પણ એક શેમાં છે? ગ્રામમાં. હવે મેં તમને વાત કરી એ પ્રમાણે ગ્રામથી મારે શેમાં કન્વર્ટ કરવાનું છે? ml-માં. તો ml-માં કન્વર્ટ કરવા માટે પહેલાની અંદર મેં સિમ્પલ કેલ્ક્યુલેશનમાં બતાવ્યું હતું કે નાઇટ્રોબેન્ઝીનને કેવી રીતે મેં ગ્રામમાંથી ml-માં કન્વર્ટ કર્યું. હવે અહીંયા આગળ આપણે નાઇટ્રિક એસિડ અને સલ્ફ્યુરિક એસિડને ગ્રામમાંથી ml-માં કન્વર્ટ કરવાનું છે. તો અહીંયા આગળ ફોર્મ્યુલા આપ્યું છે. ડેન્સિટી કેટલી છે? 1.41. ફોર્મ્યુલા શું છે? ડેન્સિટી ઇક્વલ ટુ D ઇક્વલ ટુ m/v. તો V ઇક્વલ ટુ m/v છે એટલા માટે અહીંયા આગળ મને શું જોઈએ છે? વોલ્યુમ. તો વોલ્યુમ ઇક્વલ ટુ શું થશે? V ઇક્વલ ટુ m/d. તો અહીંયા તમે જોઈ લો ફોર્મ્યુલા એ જ છે. V ઇક્વલ ટુ m/d. m મીન્સ માસ અને D ઇક્વલ ટુ ડેન્સિટી. હવે મારું માસ જે છે એ ક્યાં આપ્યું છે? સોરી, m/v. હા, માસ ક્યાં છે? અહીંયા આગળ. કેટલું જોઈએ છે? 1.4. એક મિનિટ, કદાચ કેલ્ક્યુલેશનમાં કોઈ જગ્યાએ D ઇક્વલ ટુ, એક જ મિનિટ. D equal to m/v. અહીંયા આગળ તમારું જે માસ કેટલું જોઈએ છે? 2.58 divided by 1.41. D equal to m/v. તો આપને મળશે 1.814. એ જ રીતે સલ્ફ્યુરિક એસિડ. સલ્ફ્યુરિક એસિડમાં D equal to m/v. આપણને D કેટલું છે એટલે કે ડેન્સિટી કેટલી છે સલ્ફ્યુરિકની? 1.98 સોરી 1.89 અને વેટ કેટલું જોઈએ છે? 7.9. તો 7.9 ડિવાઇડેડ બાય 1.89 એટલે તમારો આન્સર આવશે 4.2. તો આટલું વોલ્યુમ આપને સલ્ફ્યુરિક એસિડનું જોઈશે. હવે એક્ઝેક્ટ વોલ્યુમ આપણે સપોઝ ના લઈ શકીએ તો નિયર અબાઉટ વોલ્યુમ નોર્મલી લઈ અને આપણે રિએક્શન કરી શકીએ. તો આ કેલ્ક્યુલેશન એક્સેલ શીટથી પણ થઈ શકે. તમે નોર્મલી આ બધા ફોર્મ્યુલા મેન્યુઅલી મૂકીને પણ કરી શકો, પણ એક્સેલ શીટનો ઉપયોગ કેવી રીતે કેમિસ્ટ્રીમાં થઈ શકે એ બતાવવા માટે આ એક ટેબલ અથવા પીપીટીમાં બતાવ્યું, સોરી પ્રેઝન્ટેશનમાં મેં લીધું છે. આ બધા કેલ્ક્યુલેશન આપણે કરી શકીએ જે રીતે અમે હમણાં બતાવ્યા એ પ્રમાણે. અહીંયા આગળ हाँ
what is the temperature density is taken? मतलब कोई टेम्परेचर होगा ना, रूम टेम्परेचर है क्या?
किसका
डेंसिटी associated with density?
Normally room temperature means 25 to 30 degree, because density is associated with the temperature. If we increase the temperature, then density decreases. If we decrease the temperature, density increases. But here we are carrying out the reaction at room temperature, means whenever we are mixing this chemical or weighing this chemical, the normal temperature is there. Normal temperature means near about 30 degree temperature is there. So whatever the density is mentioned, that is associated with the room temperature. It is not associated with the high temperature or low temperature. It is with room temperature. So once you are having the material or calculation, after completion of the calculation, we have to go for the actual practical. Now in actual practical, here the process is given, but I will explain the process by normal or simple word, what you have to do first. As per the requirement of the chemicals, we have to weigh or we have to measure the required chemicals. As we have discussed, near about 4.2 ml we require nitrobenzene. 1.4 means near about 1.5 ml nitric acid, and near about 2.5 ml sulfuric acid we require for this reaction. Now, first of all, what we have to do? We have to mix HNO3 and H2SO4 first. When we are mixing HNO3 and H2SO4, as we know, the reaction is highly exothermic. The reason is, during the reaction, when we mix HNO3 and H2SO4, what happens first? The protonation will take place and it will convert it into nitronium ion plus water. This reaction is highly exothermic, so we have to maintain the temperature. If we do not maintain the temperature, then what happens? The evaluation or evaporation or this nitrile ion may escape from the reaction flask or beaker. If there is a loss of nitronium ion, then we can say the less amount of reactant is available, and that's why the product will not be, or proper amount of the product will not form. So to avoid such problem, we have to maintain the temperature when we are mixing HNO3 and H2SO4. So normally we have to use ice bath. In the ice bath, you have to keep your beaker, then add slowly the H2SO4 and nitric acid in a beaker. Then after, we have to add nitrobenzene into nitrating mixture or nitrating mixture into nitrobenzene. But normally we take nitrobenzene in a conical flask, and then after, with constant stirring at low temperature, again you have to maintain the temperature or reduce the temperature, and at low temperature we have to mix this compound. After mixing of nitric acid, nitrobenzene, that is called nitrating mixture, and nitrobenzene, remove the flask from the ice bath, and we have to keep this flask on sand bath. As per the procedure, we have to maintain the temperature near about 70 to 80 degrees centigrade. So better option is to use ice water bath. But sometimes in water bath, it will take longer time. The reason is, first of all, we have to heat the water bath. We have to reach up to the temperature that is called 70 to 80 degrees centigrade of the reaction mixture, and then after we have to calculate the time for the reaction. So to avoid such problem, if we go for directly, or if we use a sand bath and maintain the temperature with the constant monitoring of the temperature, then within half an hour, means for 30 to near about maximum 40 minutes, the reaction will be completed. Now, as we have discussed about the progress of the reaction we can check with the support of TLC. Now, how to perform the TLC? We have to take our 1 drop reaction mixture. Then that 1 drop of reaction mixture we have to put or kept on the TLC plate, and with this 1 or less than 1 drop, you have to take nitrobenzene. Then put this TLC plate into the solvent system. When we run the TLC in the solvent system, we will find the RF value for the particular product or material. After confirmation of the completion of the reaction, we can isolate our product. Now, for the isolation of the product, we have to reduce the temperature. And once we reduce the temperature, we can pour the reaction mixture into ice water. After pouring a reaction mixture on ice water, we will get solid material. The reason is why the conversion of liquid to solid. The reason is the product which is known as metadinitrobenzene it's in a solid form, and that's why by reducing temperature we will get the solid. Nitrobenzene, which is having liquid state, or we can call it as a liquid material. So by pouring into ice water, if reaction is completed, then you will get purely solid material. If reaction is incompleted, then some oily water droplets you will find. So it indicates the reaction was not completed, but due to the misunderstanding you have poured the reaction mixture. So if you find such difficulty, then stop continuous addition of reaction mixture into ice water. You have to again start the reaction. Now, once the reaction is completed, means you are having a solid form of your product, then you have to go for the filtration. So when we go for the filtration, as we know, the product is a solid form, so we have to collect the solid, and after that we have to purify our crude product. Now, why purification is required? As I said, some unreacted nitrobenzene may be present, and as per the reaction mechanism or the directing effect of nitro group, we will get 6 to 7% other isomers. We have to remove the other isomers by crystallization method. In the recrystallization method, we can use distilled water or distilled water plus methanol we can use. We should avoid the use of pure methanol or ethanol. The reason is, if we use pure methanol or ethanol, then nitrobenzene is highly soluble in pure ethanol or methanol. But if we use methanol plus water, then it is more advisable to get proper recrystallization. After recrystallization, we have to dry our product, and then if we have to go for the melting point of the particular compound. So as here already mentioned, the melting point of the compound is 89 to 90 degrees centigrade. So if your product is formed, then you will get the proper melting point. If product is not formed, then you will not find a particular melting point. Second thing, If impurities are there, then also the melting point is not proper. So it is required that we have to purify the reaction mixture by proper recrystallization method and collect a pure product, and then after we can go for the further analysis. Now, as per the taste, chemical taste, in here we are having two nitro group in a product. So as already said, nitrobenzene is a liquid and metadinitrobenzene is solid. So by physical taste or physical observation, we can say the product is formed. એટલે કે તમારી લિક્વિડ પ્રોડક્ટ આવે તો સમજવાનું કે આ રિએક્શન થયું નથી અને સોલિડ આવે તો આપણે કહી શકીએ કે આ રિએક્શન થયું છે. But now we have to confirm that how nitro group is present or not. So for the confirmation, we can go for the reduction. If we go for the reduction, then if nitrobenzene is there, then you will get aniline, and if metadinitrobenzene is there, then you will get metaphenylene diamine. So again, based on that, you can say the product is formed. Second, if you are having metadinitrobenzene, then we can go for the partial reduction of nitro group. Due to the partial reduction, we will get meta-nitroaniline, and if nitrobenzene only there, then you will not get meta-nitroaniline. So these are the tests we can call as a confirmatory test, that is known as chemical test. Now, based on the spectroscopy also, we can confirm the structure. Here already I have mentioned, or the data are given. If you are having nitro group, then you will get find some peaks. But if you are having two nitro groups, then there is a variation or change in the peak. So based on that IR spectroscopy or frequency, we can say in the compound we are having two nitro groups. Then based on the proton signal, that is called NMR spectroscopy. Based on NMR spectroscopy also, we can find out whether the product is formed or not. And last one is mass spectroscopy. So based on IR spectroscopy, mass spectroscopy and NMR spectroscopy, we can find out the product is formed or not. So as per the syllabus or as per the requirement, I have explained about the preparation of metadinitrobenzene from nitrobenzene. Here I am having a video which is I have downloaded from the YouTube. So I am playing that video. This video is self-explanatory that how the now you will get the idea how we have to perform the practical in the lab. Please watch it. Okay. So if you are having now any doubt regarding what we have discussed up to here, then please raise your hand first, and then after I will allow. Okay. Dishan Patel, please. Please unmute yourself and ask about your query.
હેલો
Hmm.
જે આપણે જે ડ્રાઇંગ પ્રોડક્ટ મળી એની પછી આપણે ઇથેનોલ સોલ્યુશન એડ કર્યું શા માટે ઇથેનોલ યુઝ કર્યું
મેં પહેલા જ કીધું કે ઘણા બધા ઓપ્શન્સ છે કે રીક્રિસ્ટલાઇઝેશન માટે આપણે ઘણી બધી સોલ્વન્ટ કે સિસ્ટમ યુઝ કરી શકીએ, બટ નોર્મલી ઘણા લોકો ખાલી વોટરનો પણ યુઝ કરે છે, બટ this compound is not completely soluble in hot water. So we should avoid the use of hot normal water or tap water. Second, we can use pure form of ethanol or methanol, but again in ethanol and methanol the high solubility is there, so that's why water plus ethanol is the better solvent system for the recrystallization. In the recrystallization, the condition is your material should be insoluble at room temperature, means at low temperature, and should be soluble at high temperature. So after mixing a solvent, we have to heat it, and then after we have to go for the filtration, and after that we have to reduce the temp or allow to stand for some time to reduce the temperature. So why filtration is required? That is called hot filtration is required to remove the insoluble impurities. And after that, we are going to collect the pure form of the product. And for that, we have to allow to stand for some time. So at normal temperature, we will get the crystal. So this is the reason we have to use solvent, sometimes single solvent or dual solvent for the purification of the product. Now the question of the other impurities, after completion of recrystallization, we have to filter it again, or we have to decant the excess solvent. Now when we decant the excess solvent or filter it, at that time the soluble impurities, maybe that is partial amount or less amount of orthodinitrobenzene and paradinitrobenzene, both are soluble in the particular solvent, and by this way or by this method we will get the pure form of the product, and that's why it is known as recrystallization or purification technique. બીજા કોઈને ક્વેરી છે? I think કેતન ઠાકોરનો hand raise હતું. કોઈને ક્વેરી નથી?
No, sir.
Okay, then કોણ છે? અભિષેક, બોલો.
हाँ सर, you said something about effect of temperature and nitration. तो अगर ज्यादा टेम्परेचर होता है then ट्राइनाइट्रोबेंजीन बन जाता है. So what is the theory behind it?
You are by increasing temperature we are activating the molecule, and when we are activating the molecule, the third nitration will take place. So whenever any group is entering on a substrate or attacking on a substrate, the attachment is based on the temperature. And again repeating with the reaction of nitric acid with benzene. So if you want to carry out nitration of benzene, then you require only 40-degree temperature. But once one nitro group is introduced, to introduce second nitro group, we have to increase the temperature up to 70 to 80 degrees centigrade. But if temperature is 100 or 110, then the compound is more active, and that's why the third nitration is also take place. So this is the reason we have to maintain the temperature. So if you have seen the activation energy graph in physical chemistry, temperature versus activation energy. When we increase the temperature, the activation energy is high. When we decrease the temperature, the activation energy decreases. So is it clear, Abhishek?
Yes.
Okay. Is there any other query? If not, then as per the query from the Abhishek, we are going to discuss another nitration where the temperature is less than room temperature. Means temperature is near about 5 degree, 5 to 10 degree only, and we will get the product. And in that case, means in the next preparation, if it temperature is room temperature or higher than room temperature, then some other product will form. So normally in our mind that to carry out the reaction we require high temperature, and especially for nitration, but for some nitration we have to reduce the temperature, and that temperature is near about 5 to 10 degree only. So here we are having the preparation of para-nitro acetanilide from acetanilide. So we are having acetanilide, that is called NHCOCH3 on benzene. So C6H5 NHCOCH3. Here the reagents are same, means HNO3 and H2SO4 we require for the nitration of the reaction. The reason is why HNO3. HNO3 is act as a nitrating agent, means it act as a reactant for this reaction, and sulfuric acid will act as a catalyst for generation of this NO2 plus. Once we are having this NO2 plus, then only it will enter in the cloud or pi electron cloud of acetanilide. But the characteristic of this group plays an important role. This NHCOCH3, as per the mesomeric effect, as per the inductive effect, as per the resonance effect, this group is act as a orthopara directing. And second thing, this group is ring activating group. Ring activating group means what? It giving electron to the ring. When it giving electron to the ring, so ring will gain negative charge. Means benzene or phenyl ring having negative charge. And as we have seen, NO2 plus which having positive charge, deficiency of electron. So the interaction will be more faster as compared to the previous reaction, that is called nitrobenzene. The reason is nitro is ring deactivating group and NHCOCH3 is ring activating group. So what happened? The para position will gain negative charge. Same way ortho position will also gain negative charge. Both position having negative charge. But as per the directing effect, whenever the mesomeric effect is powerful, then the more stable resonating structure if negative charge on para position, and that's why the major product will be formed based on the most stable resonating structure. Second thing, here the steric hindrance is there. So due to the steric hindrance, it will allow partially or little amount of nitro group over here. Otherwise, maximum product will be formed based on the directing effect of NHCOCH3, and which is known as para directing effect. So para nitroacetanilide is a major product. Second thing, here the temperature, as I said, this group is ring activating group. NHCOCH3 is a ring activating group, and that's why we require low temperature. Here another acid we have to use, that is called acetanilide, acetic acid. The reason is this acetanilide is in a solid form, and to dissolve this acetanilide we require acetic acid. So with the support of solvent we can prepare a homogeneous mixture and we can carry out the reaction. The reaction mechanism, as I said, the first step will be same. Nitric acid will react with sulfuric acid. We will get NO2 plus, and then NO2 plus will react with acetanilide. As per the directing effect of NHCOCA3, it is orthopara directing, but the most resonating structure, that is called para position. When negative charge on para position, that will be the most stable resonating structure, and that's why NO2 plus will attach at the para position. Then after deprotonation will take place, and due to this deprotonation we will get para nitroacetanilide as a major product. Now mole ratio already I have explained in the previous presentation. In that I have explained about with the nitrobenzene. In that nitrobenzene we have taken, then molecular weight of nitrobenzene was 123. Here we are going to start with acetanilide. So the molecular mass of acetanilide is 135 gram, 135.16 gram. Now if we start the reaction with 5 gram, then what we have to do? 5 divided by 135. So the actual mole is 0.036. Now we are having 0.036. Then 0.036 into 1 equal to 0.036 for nitric acid, and 0.036 into 2 for sulfuric acid. So we are having 0.073 mole for sulfuric acid. Now we have to convert it into gram, mole into gram. So what we have to do? Mole into molecular weight. 0.036 into molecular weight, 0.073 into molecular weight. So this will be in what? In gram. But as we know, the sulfuric acid and nitric acid, these both are in liquid phase. So what we have to do? We have to go for the formula that is called D equal to M by V, where V equal to M upon D. V means volume which we require. M means mass. So mass we are having, that is 2.233, and D, that is 1.41. So what will be the ml for the required reaction? 1.6.5 and 3.8 ml for sulfuric acid. So based on that we are having now ml. We have to use this mole ratio and we have to start the reaction. First of all, we have to weigh the acetanilide. Lenu vajan karo. Then after add glacial acetic acid. As I said, glacial acetic acid is act as a solvent for this reaction. Once we add glacial acetic acid, we will get a clear solution. If clear solution is not available, then we can heat in the reaction mixture into water bath. After heating, you will get the clear solution. After that, if required, we can go for the filtration. If not, then you can directly go for the next step. Then we have to insert our flask into the freezing mixer or ice bath. Why the freezing mixer or ice bath? Because for this reaction we require a lower temperature, means only 10 degrees centigrade or less than 10 degrees centigrade we require. So we have to keep our flask which containing acetanilide and glacial acetic acid into a freezing mixer. After that we can add sulfuric acid or we can add the nitrating mixture. Both way we can do. First of all, we have to add sulfuric acid. Then after we can go add nitric acid, or we can previously prepare the nitrating mixture, means mixing of nitric acid and sulfuric acid. This directly, this nitrating mixture directly we can pour into the reaction mixture. When we are adding this nitrating mixture, the reaction is again exothermic, so constant stirring is required, and also we have to maintain the temperature below 10 degrees centigrade. So instead of glass rod, you can directly use thermometer with stirring as well as the measuring the temperature. But the better option is drop by drop addition with the we have to start the reaction mixture with the support of glass rod. If we use the thermometer, then sometimes the bottom or tip of the thermometer may be broken due to the heating or strike with the flask or wall of the flask. So we have to avoid such thing. After complete stirring and mixing of the reaction mixture, we have to stir it for 20 to 30 minutes at low temperature only. And after that, we can keep the flask out from the freezing mixture, and then after we can pour the reaction mixture on ice water or crushed ice, or you can directly add crushed ice into beaker. Whichever way is preferable, then that we have to follow, but better is we have to pour this reaction mixture on ice water which is in a beaker instead of this conical flask. After that we can go for the filtration, and after filtration we will get the pure product, crude product, and then after we have to recrystallize it. Now why recrystallization is required? Because during this reaction, if by chance temperature is greater than 10 degrees centigrade, then formation of or amount of this nitrobenzene may be high. That is called orthonitroacetanilide will be high, and to avoid such problem we have to maintain the temperature that is called less than 10 degrees centigrade throughout the reaction. Again I am repeating, if temperature is increases during the mixing of nitrating mixture, then the amount of orthonitroacetanilide will also increase. And to avoid such problem, we have to maintain the temperature below 10 degrees centigrade. The reason is you have given a task to prepare para-nitroacetanilide. After completion of the reaction, we can go for the recrystallization. As I previously said, to check the progress of the reaction, we have to perform the TLC, and based on TLC, you will get the idea about the reaction is in progress or not. But the method is standardized method, well established method, so definitely you will get the product. Here again I am showing you the video where you will get some information. Preparation.
સાહેબ અવાજ કરો ને.
एक मिनट.
સર વોઇસ નહીં આવતો.
અહીંયાથી તો વોઇસ ક્લિયર જ છે.
સર આવતો જ નથી પણ અમે અકાવી લેવી છે ચાલશે.
પોસ્ટ વિડિયો ગ્રુપમાં શેર કરી દો સર કાલે.
સર પહેલા વાળામાં નતો આવતો. પહેલા વિડિયો ચાલુ કર્યો છે ને.
એક જ મિનિટ. ઉભા રહે એક જ મિનિટ. હવે આવે છે અવાજ?
ના સર હજુ નથી. ઓકે, તો વિડીયોઝ જે છે તે હું શેર કરી દઈશ. આ બંનેમાં કોઈને કોઈ ક્વેરી હોય તો પૂછી શકે. છે કોઈને ક્વેરી?
ના સર.
ઓકે. નેક્સ્ટ હા કોણ છે? પટેલ ઋષિ બોલો.
કેલ્ક્યુલેશન સમજાવી દેજો ને મોલ ઉપરથી જેટલા ml લઈએ છીએ.
એમાં કેલ્ક્યુલેશનમાં ખાલી D equal to m/v ફોર્મ્યુલા.
એની સર પેલું મોલ એક્ચ્યુઅલ મોલ આપણે જે શોધીએ છીએ ને એ સર.
કયું? અહીંયા આગળ સ્ક્રીનમાં બતાવ્યું છે.
હા એક્ચ્યુઅલ મોલ જે ગણીએ છે અને એના ઉપરથી આપણે એમાઉન્ટ ઓફ સબસ્ટન્સ રિક્વાયર્ડ લઈએ છે ને સર.
એમાઉન્ટ ઓફ સબસ્ટન્સ રિક્વાયર્ડ. હા ઓકે. સપોઝ અહીંયા આપણે 5 ગ્રામથી સ્ટાર્ટ કરવા માંગીએ છીએ. એ જે મોલ છે સોરી 5 ગ્રામ આપણે મટીરિયલ લેવા માંગીએ છીએ એના મોલ ક્યાંથી આવ્યા? તો પહેલા તો 5 divided by molecular mass of acetanilide. So 135.16. Based on this calculation or we will get this 0.036 આ મળશે. બરાબર. Now this is the mole of acetanilide. તો એના બેઝ ઉપર નાઇટ્રિક એસિડ કેટલો જોઈએ છે? તો into 1. એના બેઝ ઉપર સલ્ફ્યુરિક એસિડ કેટલો જોઈએ છે? into 2. So we are having now this value for nitric acid and for sulfuric acid. Now for sulfuric acid and nitric acid, both are in liquid form. So we cannot go for the weight, directly weight. But here from mole we have to convert it into weight. So how we can convert? So this 0.036 into 63, 0.073 into 98.078. એને કેલ્ક્યુલેશન કરીશું અથવા મલ્ટીપ્લાય કરીશું તો તમને કઈ વેલ્યુ મળશે? આ મળશે. This is called actual amount required for the reaction. But again the issue with these two compounds, both are in solid liquid form. આ છે liquid. So again the one more issue is what? We have to convert liquid weight into volume. So for that there is a one formula D equal to m/v. We are having value of D. We are having value of mass m, but we are not having value of v. So when we do v equal to m/d, we will get this value. એટલે આ વેલ્યુ મળશે નાઇટ્રિક એસિડ માટે, આ વેલ્યુ મળશે આપણે સલ્ફ્યુરિક એસિડ માટે. તો એટલા ml લઈને રિએક્શન કરવું. ઓકે. હવે ક્વેરી છે આમાં?
ક્લિયર સર.
Now next one is preparation of methyl orange and methyl red. This reaction is known as diazotization. So diazotization means what? Aza means one nitrogen and diaza means NN. Now this NN will be in this form, NN form or N double bond N form or N triple bond N form. But when we are talking about diazotization or diazotization reaction, then this form will be there, that is called N double bond N. Now how we convert this N double bond N or generate N double bond N? For that we require one nitrogen. Now this nitrogen must be in aromatic nature. So we are having ArNH2. If you are having primary amine, and that amine should be aromatic in nature. So if you are having primary aromatic amine, then only we will get stable diazonium compound. Means Ar N double bond N X. This X may be Cl, HSO4 minus any other group. But this will be synthesized, or we can synthesize with the support of or from aromatic amine only. This is stable at room temperature, not at room temperature, but at low temperature, and the reaction mixture temperature must be 0 to 5 degrees centigrade only. If temperature is greater than this, then the decomposition of this part will take place, and we will get some reactive intermediate, maybe Ar plus or Ar free radical. It depends on how the decomposition will take place, but we will not have now diazonium salt. We are having some other reactive intermediate. So to avoid this issue, we have to carry out diazotization reaction at 0 to 5 degrees centigrade only. And during this reaction, we are converting aromatic amine into what? N double bond N. That's why diazo compound. That's why it is known as diazotization. In the previous reaction, we have seen that we have converted or introduced nitro group. That's why we have called it a nitration. And here we are converting into diazo groups. That's why it is known as diazotization reaction. You are very much familiar with this reaction because since school time, means 11th standard, you have performed this test for detection of primary aromatic amine. This test is very much useful for the detection of primary amine, secondary amine, and tertiary amine. Okay, you can distinguish primary amine, secondary amine, and tertiary amine with the support of diazotization test. You have performed as a test, but now we are going to use this reaction for preparation of important dyes, that is called methyl orange and methyl red. Now I think you have heard this word methyl orange and methyl red. Both are known as indicator. Means with the support of aromatic amine, we are going to synthesize indicator, and these indicators are used for check the pH of the particular reaction or particular material or particular compound. So with the help of diazotization reaction, we will prepare indicators methyl orange and methyl red. Now first preparation is associated with methyl orange. In the methyl orange, we can prepare or synthesize methyl orange from sulfanilic acid. Now sulfanilic acid, the name itself says sulfanilic acid means sulfur containing group is there, and sulfur containing group means SO3H group is there, which is attached with the phenyl ring, one side NH2 group. So both types of functional groups are present. One is acidic, another is amine, means base. So acid and amine both are present on one compound. When both are present on one compound, then we cannot say it is a completely acid. We cannot say it's a completely basic. That's why it is known as amphoteric nature of the compound. Means this compound is behaving or will be soluble in both types of reagent. If we add acid, then basic group will interact. If we add base, then acidic group will interact, and it is soluble in acid and base both. That's why it is known as amphoteric nature containing compound. Now for this preparation we have to dissolve this compound in a particular substance or reaction mixture. So here we are going to dissolve this compound in a sodium carbonate solution, NaHCO3. Reason is this is amphoteric nature containing compound. So if we add base, the salt formation will take place and replacement of this hydrogen will take place, and as a result what we will get? Sodium salt. So here sodium salt of the sulfonilic acid will form. As we know, sodium salt of any compound is water soluble. So that's why we will get a clear solution. If required, we can filter it. If not, then we can directly go for the next step. Now for diazotization step, what we require? For diazotization step, we require nitrous acid, HNO2, but nitrous acid is not available in the lab. So how we can prepare the nitrous acid during the reaction? For that we have to use this NaNO2 plus HCl. First NaNO2, which is water soluble. So by addition of water, what we will get? Na plus NO2 minus. Same way HCl is also water soluble. So what we will get? H plus and Cl minus. So Cl minus will react with Na and NO2 will react with H plus. So as a result, we will get NaCl plus HNO2. Now this HNO2 we have synthesized in the flask or prepared in the flask. That's why it is known as in situ generation of nitrous acid. Again I am using word in situ generation, એટલે કે લેબ ની અંદર અવેલેબલ નહોતું અથવા નથી, તેને આપણે એક બે કેમિકલ મિક્સ કરી ફ્લાસ્ક ની અંદર પ્રિપેર કર્યું છે, એટલે આપણે એને શું કહીએ છીએ? In situ generation of nitrous acid. Now this nitrous acid will act on the primary aromatic amine. When it attack on this primary aromatic amine, we will see the different reaction mechanism steps, but when they react with each other, it will convert it into N double bond NCl. We can write this form N double bond NCl, or you can write N plus triple bond N and Cl minus. So both are known as resonating structure. So what we can call it is diazonium salt will form. Then after, once diazonium salt is formed, then after immediately we have to mix N-dimethyl aniline. When we mix N-dimethyl aniline into this, then coupling reaction will take place, means replacement of this Cl take place and the phenyl group will be attached, and finally we will get the methyl orange. Now the most important parameter is throughout the reaction we have to maintain this 0 to 5 degree centigrade during the reaction. If temperature is high, then what happens? Decomposition of this will take place. Decomposition of diazonium salt will take place. So both will decompose at high temperature, and that's why we have to maintain a proper temperature, and that temperature is 0 to 5 degree centigrade throughout the reaction. After completion of the reaction, we can neutralize it. When we neutralize it, the sodium salt will convert it into acidic SO3H. If we do not neutralize, then also we can use sodium salt of methyl orange. Sodium salt of methyl orange. Both way we can use it. Now we are going to discuss about the reaction mechanism. As I said, in the reaction, what we require? We require aniline. Now instead of aniline, here I have given example of aniline, but instead of aniline, we can say R equal to SO3H. When R equal to SO3H, it means it is known as sulfonilic acid. This one is known as sulfonilic acid because we have introduced or we have used R equal to SO3H, so sulfonilic acid. During the reaction, we have seen that nitrous acid is required, but nitrous acid is not available in the lab. That's why we have to mix NaNO2 plus HCl. When we mix this, first of all, we will get HNO2. Now, there are different methods by which we can introduce or we can generate nitrous acid. Some people are adding sulfuric acid and sodium salt of sulfonilic acid. Then after we can introduce NaNO2. Some people are what they are doing. They are using sodium salt of sulfonilic acid, then mix with NaNO2, and after that they are adding this HCl. So whatever way is preferable, the preferable way is first of all prepare a solution of sulfonilic acid, then add NaNO2, and then after add HCl. Why this is required? You can check the progress of the reaction very easily with the help of starch iodide paper. This is the test we have to perform during the reaction. Or if we have introduced this HCl into this, then slowly with the control rate we have to add NaNO2. As I said, whichever method you want to prefer, you can prefer, but as per the conveniency, as per the volume, we can change our method. Now the question is from where we are having NO2 plus. As we are talking about when we mix NaNO2 plus HCl, we are having nitrous acid. So what happened? 2 mole of nitrous acid are mixed with each other and it will convert it into NO2, NO plus H2O. This will form. Okay. Here the long procedure or steps are there. Right now I am not going to discuss those steps, but if required I will explain. But as per the reaction between these two, nitrous acid NaNO2 plus HCl, first of all 2 mole of nitrous acid react with each other and it will convert it into NO2 plus, 2 moles of NO2 plus, and water will be formed. This NO2 plus NO plus having deficiency of electron, nitrogen having positive charge, and this nitrogen having lone pair of electron. So this nitrogen act as a base and it will attack on this. As a result, we can say nitro group is attached over here, but nitrogen has donated its electron to this nitrogen. That's why nitrogen having positive charge. We can say ammonium salt will form or ammonium nitrogen is there. So immediately the breaking of this nitrogen hydrogen bond, an electron will transfer over here, and as a result we will get nitrosoamine NHN11O. Now from this nitrosoamine further it react with HCl. When it react with HCl, first of all this oxygen will bind with hydrogen and as a result the protonation will take place and we are having now OH plus. Now oxygen having positive charge. Then after further migration of electron will take place from nitrogen to oxygen, so it will convert it into OH. After that this electron will shift over here, so it will convert it into N11N. When it converted into N11N, H plus will be eliminated. So finally we are having now N11NOH. Now this N11NOH when react with HCl, it will convert it into N11NCl. But before that, what happened first? This hydrogen having deficiency of electron, the reason is it is in the form of H plus and this one is in the form of Cl minus. So hydrogen will attach with the oxygen and it will convert it into OH2 plus. Now this OH2 plus will be eliminated as a water. So loss of water is there. So we will get N plus. Now this N plus is combined with Cl minus, and finally we are having now R C6H5 R equal to SO3 H or Na, whatever. Then N double bond NCl. So diazonium salt will form. Then after we are, as we have discussed, we are having two different resonating structure. So it is in the form of N plus triple bond NCl minus. So this is the reaction mechanism for generation of diazonium salt from amine. Here as a amine we have taken sulfanilic acid. So we can say the salt, diazonium salt of sulfanilic diazonium salt will form from sulfanilic acid. Now, as we have discussed, we have to maintain the temperature 0 to 5 degrees centigrade throughout the reaction. If we do not maintain temperature, then what happens? First of all, breaking of this nitrous acid will take place and it will convert it into NO plus NO2. When it converted into NO plus NO2, there is a loss of this 2. બંને reaction flask માંથી નીકળી જશે. So we have to maintain the temperature throughout the reaction. Second, if we do not maintain the temperature over here, then what happens? This diazonium salt will immediately convert it into N2. It will convert it into N2 and positive charge will be on the ring. Ring ઉપર કયો charge આવી જશે? Positive. When the ring having positive charge, the positive charge will bind with Cl minus and we will get the unwanted product that is called chloro substituted product will form. This is unwanted product during the reaction. Second, in the reaction we are having water also. So from water also we will get the ionization of water will take place and it will convert it into H plus and OH minus. Then some amount of OH minus may attach with over here. It means they will attach over here. So unwanted phenol is also formed. So these are the issues with diazotization reaction. To avoid all issues, આ બધા ઇસ્યુ તમારે avoid કરવા હોય, we have to maintain the temperature that is 0 to 5 degrees centigrade throughout the reaction. Then only we will get the diazonium salt. હમણાં જે મેં explain કર્યું છે, આ બધી વસ્તુ તમને વાઇવામાં પૂછવામાં આવશે, તમારે યાદ રાખવાનું રહેશે. Now, the next step that is called coupling reaction. As we have discussed, the coupling reaction will take place and the coupling reaction will take place and paraposition of N dimethyl. Means here N dimethyl, this group is also known as ortho-para directing. Second thing, steric hindrance is there. So no attachment over here. Only the attachment will be possible on para position. Now why the attachment will be possible on the para position? So as we can see, this group having negative charge on ortho position and negative charge on para position, but due to the steric hindrance, the group will not bind over here. It will bind on this para position only. As we have seen the process in the previous step, what we are having N plus Cl minus. When we are having N plus Cl minus, this N plus will bind with this, where it bind, N will bind over here, and finally we will get diazonium, we will get methyl orange. So here you can see, and from N double bond NCl, Cl will be eliminated and this para position will attack on this position. So we are having N double bond N, which is bind with the para position of N dimethyl, and then after removal of H plus, that is called deprotonation, will take place. This proton will bind with the Cl. So here we can say Cl is eliminated during the reaction. If small molecules are eliminated during the reaction by combining of two big molecules, then we can call it a condensation reaction, and finally we will get this compound N double bond N. So this is called methyl orange. Okay. Now the question is sodium salt. This we are going to use as a indicator. So indicator should be soluble in a particular solvent, and that's why we have to use sodium salt of methyl orange. Now how we can prepare the sodium salt? Because as we have seen, during the reaction HCl is generated. Throughout the reaction, highly acidic condition is there. So these will be converted into what? H. But after completion of the reaction, we have to add NaOH and we have to convert it into sodium salt. This is a hidden part of the reaction, but actually we have to do or perform during the reaction and we will get sodium salt. So mole ratio already I have discussed in the previous two preparations, so I'm not going to discuss, but as per the calculation what we require, 1 mole of sulfuric acid, 1 mole of sodium bicarbonate and 2.5 mole of HCl. Now as per the calculation we require 1 mole of sulfuric acid, but if you go through the reaction mechanism carefully, then it required 2 mole of HCl, not 1 mole. And 0.5 mole is in excess to stabilize the diazonium salt. Diazonium salts are stable in acidic condition at low temperature. Okay, and to maintain the temperature, to maintain the quality of diazonium salt, we have to use 2.5 mole of sodium, 2.5 mole of HCl in the reaction. Little amount of sodium nitrate, sodium nitrate means NaNO2 we require, that is 1 mole. N-dimethyl aniline, that is 1 mole. Acetic acid as per the requirement. Now what is the role of acetic acid? Acetic acid we can use to dissolve this N-dimethyl aniline. N-dimethyl aniline is a water insoluble. That's why we have to use. What is the use of NaOH in this reaction? As we have discussed, during the reaction SO3Na will convert it into SO3H. So avoid such problem, we have to add NaOH, and whatever amount of SO3Na was in SO3H form, that all can be converted into SO3Na with the support of NaOH. And finally, what is the role of this NaCl in the reaction? As we are talking about the sodium salt of methyl orange, which is soluble in water. So to isolation or to carry out isolation of sodium salt, આપણે જાણીએ છીએ કે સોડિયમ સોલ્ટ વોટર સોલ્યુબલ છે, પણ એ વોટર સોલ્યુબલ હોવા છતાં વોટરમાંથી એને પ્રેસિપિટ આઉટ કરવું હોય તો તમારે બીજો એવો સોલ્ટ નાખવો પડે કે જે હાઈલી સોલ્યુબલ હોય એઝ કમ્પેર ટુ સોડિયમ સોલ્ટ ઓફ મિથાઇલ ઓરેન્જ. અને NaCl એ હાઈલી સોલ્યુબલ ઇન વોટર છે, એટલે NaCl તમે એડ કરશો તો શું થશે કે NaCl વોટરમાં વોટરની અંદર ડિઝોલ્વ થશે અને જે પ્રોડક્ટ છે એટલે કે સોડિયમ સોલ્ટ ઓફ સલ્ફાનિલિક એસિડ એ તમારા પ્રેસિપિટ આઉટ થશે. અગેન સોડિયમ સોલ્ટ વોટર સોલ્યુબલ હોય છે કોઈ પણ પ્રોડક્ટના, પણ બીજો જો હાઈલી સોલ્યુબલ સબસ્ટન્સ આપણે એડ કરીએ તો તમારું લેસ સોલ્યુબલ પ્રોડક્ટ છે એ પ્રેસિપિટ આઉટ થઈને બહાર આવે અને તમે સોડિયમ સોલ્ટને પ્રેસિપિટ આઉટ કરી શકો. સો ધીસ ઇઝ કોલ્ડ સોલ્ટિંગ ટેકનિક ફોર isolation of the product. Now, as we know, methyl orange we can use as an indicator. So when it is red, when it is yellow. So at acidic pH, methyl orange gives red color, red orange color. The reason is, as we have talked about, if this is the normal nature, means it is in which form? Sodium form. it is in a water soluble. So at neutral pH. So neutral pH, this is having this color, yellow color. Name is methyl orange, but color is yellow because of the sodium salt. But when we add acid, the sodium salt will convert it into what? SO3 OH. એટલે કે આ H અહીંયા Na હતું, એને કોને રિપ્લેસ કર્યું? Ha, અને બની જશે ઓરેન્જ કલર. એટલે રેડ ઓરેન્જ કલર તમારું ફોર્મ થશે એસિડિક pH માં. pH ફરી પાછી તમે એસિડિક માંથી ન્યુટ્રલ કરો અથવા એસિડિક માંથી બેઝિક કરો, એટલે કે આલ્કલાઇન કરો, તો ફોર્મ શું થશે? SO3Na. અહીંયા પણ Na છે, SO3Na. So if it is an SO3Na, then this color. If it is in a form of SO3H, then this color. So we can say it's showing two colors in different pH. બરાબર? જુદા જુદા pH છે, એનો જુદો જુદો કલર આવી શકે. પ્રોસિજર જે એક્સપ્લેન કરી છે એ અહીંયા આપી છે, પણ અહીંયા લિંક છે, લિંકની અંદર હું એક્સપ્લેન કરી દઉં છું કે અથવા તમને બતાવી દઉં છું.
Good evening, ladies and gentlemen. We've gathered here today to celebrate a very special occasion.
ઓકે, આમાં મિથાઇલ ઓરેન્જમાં કોઈને ડાઉટ હોય તો પૂછી શકે. છે કોઈને કોઈ ઇશ્યુ કે ખ્યાલ આવી ગયો છે?
ખ્યાલ આવી ગયો સર.
Okay. So I'm moving towards the next preparation. Preparation of methyl red. Now methyl red we can prepare from antranilic acid. Methyl orange we have prepared from sulfanilic acid, and this one is from antranilic acid. As discussed earlier, in sulfanilic acid we had SO3H group, where in antranilic acid we are having carboxylic acid, that is called COOH group. Now COOH and NH2, so both groups are present, that's why we can call it a amphoteric nature containing compound. Now here in this reaction we have to take antranilic acid, then after we have to add NaNO2 plus HCl at 0 to 5 degrees centigrade. When we are mixing this compound, the flask must be in ice bath, and we have to maintain the temperature throughout the reaction. Then we will get N2Cl, means diazonium salt will form. After completion of diazonium or formation of the diazonium salt, we have to add N-dimethyl aniline in acetic acid. Means acetic acid solution containing or having N-dimethyl aniline. When we are adding this compound, that is called N-dimethyl aniline to diazonium salt, the coupling reaction will take place and we will get the product. Its name is methyl red. Here the reaction mechanism and other conditions are the same as per the methyl orange. Instead of SO3H group, we have to consider COOH group at ortho position 2 NH2. So we can say everything is same. So here the mechanism is not going to discuss. Okay, because everything is same. The procedure or the requirement of chemical, in the requirement of chemical also, instead of sulfanilic acid we are having antranilic acid. Remaining things are the same. Mole ratio is also almost same. Instead of sulfanic acid we have to take antranilic acid, so mole ratio will be same, but the quantity of the substance required will be differ due to the change in the molecular mass of antranilic acid and sulfanilic acid. Here we are having two reference book, and you have to use those reference book. One is AI Vogel and second one is Manin Sonder. So with the support of reference book you can go through in detail. Today morning I have already shared the PPT in your group, so you are having the PPT. If you wish to download the video, it is available on the MS Team. You can download it and you can use it for further reference. So as per the task given to me, I have completed nitration and bromine diazotization, 2 reactions for nitration and 2 reactions for diazotization. So total 4 practicals are covered by me. If you have any question or query, then you can ask right now. Then after, other teachers will take care of their practicals. So for other practicals you have to contact respective teachers and they will guide you when they are going to take their practicals. Okay, but if you have any question or query related to the preparations explained by me, you can ask. Otherwise I think I should leave the meeting, because in the beginning there were 125 or 30 students were there. but at present only 53 students are there. So it shows that students are not interested, means 50% students are not interested in the practicals or to attending such classes. But as per part of my duty, I have done my duty. Rest is with students. What they want to do, they can do. Okay, thank you one and all.